Hi guys, and welcome back to laptop repair case study. So today we received an HP laptop for repair. So this is a no power case, so it doesn't turn on. So let us see whether we can fix this today. Okay. The laptop is not drawing any current. So let me check whether we have a voltage on the adapter. Yes, 19.63 volt is there. But the laptop is not taking any current. So I think the problem is actually on the main power rail. So we have first and second MOSFET on the main power rail after the DC jack, which switches the 19 volt into the motherboard, and then only we will get the main power rail. So if the main power rail is absent, we will get a similar reading like this one here. Now we are reading around 0 ampere, nothing. So basically I think the problem is on the DC in connector and then to the first and second MOSFETs. Okay, so now let me open the laptop and start our diagnosis. Okay, so you can see the laptop has already went to some other places for repair. So I don't know whether we can fix this today. So anyhow, we will try our best. So opening the laptop. All right, so it's a good laptop. So here we have the GPU and the CPU as well. So we have two fans for instant cooling. So someone has left two screws on this side here. Okay, so previously the person who checked it forgot to remove these screws from here. Okay, now let me take this out. So we should not mistakenly place the screws inside, because at any time anywhere we will get 19 volt, and beside that we will have just 3 volt LDO. So if that shorts, LDO means the DC chip will suddenly go off. Okay, so now let me connect the adapter. I need to check the voltage on the DC jack. Yes, we have 19.6 volt that is present. So main power rail, where can we check the main power rail? So we don't have any electrolytic capacitors, the ash color capacitor for checking that. We can find an upper MOSFET. Okay, so let me check what about this one here. No, we don't have a main power rail. Okay, so how can we find an upper MOSFET? So always the upper MOSFET drain is connected to the 19 volt. So these are all dual MOSFETs, so we cannot check it directly. Anyhow, we can check here. Okay, these are single MOSFETs. So always drain side is connected to the 19 volt line, and also the source is connected to the inductor. So you can see here. Yes, so this must be the lower MOSFET and this must be the upper MOSFET. Always the lower MOSFET source is connected to the ground. Okay, so one probe on ground and the other probe on this point, and we are having a buzzer. So this is the lower MOSFET, and the lower MOSFET drain is connected to this inductor, and the upper MOSFET source is connected to this inductor. So we have 19 volt, which is the main primary line, connected to this point here. Okay, and checking the voltage there. So we don't have anything. Okay, so I think the charging section or the charger IC is on the other side, which switches the 19 volt into the motherboard. First and second MOSFETs are on the other side. So let me take out the motherboard and start our diagnosis. Okay, so now the board is out and I can spot some components actually missing on this motherboard here. So the people who previously diagnosed this motherboard removed some regulators, MOSFET and resistors, and they did not replace it back. So actually this is going to be a tough repair, I think, because we don't know what are the components removed in this motherboard. Okay, so actually we should have schematics for this motherboard, and board view, then only we can repair this motherboard. Otherwise we can't, or it will be more challenging. So because if you look at this regulator here, you can see the regulator is missing, and also the resistors on this side is also missing. You can see one of the resistors here. Yeah, this one, a capacitor, and there were some resistors in this place, and that is also missing. So actually we should have schematics and board view, at least schematics, then only we can repair this motherboard here. So it will take time, and also this one is also missing, this IC. And on this side, so this is the V in MOSFETs, first and second MOSFET. The second MOSFET is missing, and also we should have 2 to 3 resistors here that provide the gate voltage for each of these MOSFETs. That is also missing. And on the other side, and this IC is also missing. I don't know what is this for. So we should check other sections as well if anything is missing. So I'm going to inform this to the customer, and I'll say that it is going to take time and it's going to cost more for him. So if he agrees that, then I will start the repair. So basically we can focus one by one, only on one section. First we will focus on one section and finish it off, then we can move forward. So before asking him, I need to confirm whether I have a schematics for this motherboard here, and also at least the schematics. If you don't have the board view, okay, no problem. And if we have the board view and schematics, then we are blessed actually. Okay, so continuing the repair after 2 weeks, so the customer agreed with the cost that would take to repair this motherboard, and I have already replaced the regulators and some important resistors in this motherboard. And actually it was a tough repair because I couldn't find a schematics or board view for this motherboard, and it took me for more than 2 hours to find the exact component, especially the regulators and some resistors that was missing in this motherboard. And I used some techniques to find those regulators, and I will let you know later in this video. Also, I wanted to say something to the repair community that don't do this kind of a job when you undertake a repair. At least replace the regulators and the components back as much as possible in the motherboard when you are returning it to the customer if you can't repair that motherboard. So it is like a mutual understanding between the technicians. So if you are not replacing the regulators and the components back, then you are giving more trouble to the technician who is going to undertake this repair in future. So whenever you are removing a regulator in a particular section, so if the regulators are missing, it's not a problem, but if any components surrounding the regulators are missing, then it is going to be a big problem. Such as if the resistors are missing beside the regulator, it is going to be a big problem, and you may not find the exact value when you are replacing the resistors in that particular place. So always have an eye on the surrounding components when you are removing a regulator, and maintain a good airflow so that you don't blow away other components beside the regulator. So it is very important to keep in mind. Okay, so let me ask a question. How would you handle if you were in this situation, if you received a motherboard in this condition which has no schematics and no board view? So how would you handle it? So I use a technique called substitution method. So it is not a rocket science, so I call it as substitution method, which is you need to compare the schematics which is similar to this motherboard here. So here we have the part number, which is this one here. Now you need to find a schematics for this one. If you don't have schematic, you will find other similar schematics with different part number. So you can refer that schematics and compare it with the actual components in this motherboard. Most probably, if you have the last numbers with different numbers and letters, mostly the power sections will be similar. So you can compare it and see it. So what I did was, in this motherboard, I just compared the pins on the schematics and checked its pin on this actual motherboard here, such as the ground pin, the supply pin, and also the enable pin and things like that. So when you confirm those things, then you can actually find the exact regulator on this motherboard here, or the exact IC on this motherboard. So as much as you find and check the components, check the pads on this motherboard, you can confirm it much more the actual regulator on this motherboard. Also, I have a habit of collecting scrap motherboard that has schematics and board view so that I can easily find the components through the schematics and spot them using the board view so that I can easily replace it in another motherboard. I did the same way here, so I replaced this 3.3 volt regulator from another scrap motherboard, and two of these resistors were missing, and I took the resistors from the scrap motherboard and replaced it here. And on this side, here we have the RAM regulator, and this regulator also was missing, and I took it from another scrap motherboard. And also two of the resistors also was missing. I took it from the scrap motherboard. And I don't have the resistor packages, and I usually grab things from the scrap motherboard, so it will be easy. Because on sometimes you will not find the exact value of resistors on some motherboards if the resistance values are odd, something like 255 or 301, like that, so you can't find it. And if you look at the schematics, their tolerance value will be around 1%, so which means it should be only difference plus or minus milliohms, so you can't find it like that. So it is better to have many scrap motherboards that has board view and schematics so that you can easily grab things from them and replace it on the motherboard that you are taking for a repair. Okay, so let me quickly recap what I did in this motherboard so far. So you are looking at this regulator here. Yes, this one. So this is your 3.3 volt regulator IC that provides 3.3 volt inductor and 3.3 volt LDO voltage. So some of these resistors were missing here, and most importantly the feedback resistors were missing. And if the feedback resistors were missing, then your output voltage will be abnormal and it can be a problem. So if you take above this regulator here, so this has the integrated upper and lower MOSFET, and it can be a plus point because if you remove the regulator, then there won't be any short through the upper and lower MOSFET into the load. So, and I would say thanks to the previous technician who have removed the second MOSFET from this place here, from the B-in line. So the second MOSFET was removed and I have replaced it back. So if the second MOSFET was there and if he powers the motherboard, then it could be a problem. On this case, there won't be any problem on this case here because the regulator was missing and the upper and lower MOSFET actually inside the regulator, so it is not a problem. However, if you look at this point, so this section, this is a RAM section, and on the other side this regulator also was missing, and some of the resistors nearby, I think these two were missing, and these are also on the feedback line and enable signals. So if the regulator is missing from this point, we still have the upper and lower MOSFET on this side here, which is this one. And now if you power the motherboard, what can happen, at any time your upper MOSFET can short and 19 volt can pass to the load. So when you take the load of the RAM section, so it supplies the voltage for the RAM module and also for the CPU. So at any time your CPU can severely damage with 19 volt input into the CPU. So you should not always provide the power without a regulator in a particular section. So even though your regulator is shorted, always place the regulator and power the motherboard, or at least remove the upper MOSFET and power the motherboard. Then only your motherboard will be safe. So I would say thanks to the previous technician who had removed the second MOSFET from this place here, which is this one here. So you know that initially I had plugged in the adapter, and if there was a MOSFET on this place, it can go straightly to the upper MOSFET of the RAM section, and it can short at any time and go straightly into the CPU, the 19 volt. Okay, so the repair is almost 90% complete except one section, and I wanted to repair it in live so that you can understand the importance of resistors in a particular sections. So you can take any electronics, so resistors play an important and critical role in any electronics. Okay, so now let's go for a test. So connecting the adapter, look at the ampere reading on the DC power supply. Yes, 33 milliamps. Okay, let me press the power button. Yes, you can see the power button light, and the ampere is around 700 milliamps. So the board has turned on and the fan is spinning. So I think, yeah, RAM is there. Okay, so now let me connect the mouse and see whether we are getting a display. The board is recycling, restarting again and again. Look at the ampere reading, 600 milliamps. Okay, so it took around 1.4 ampere and then back to 600 milliamps. So the board is behaving abnormally. Wait a minute. Yes, so we got the display. Now it is working fine. So the fan is spinning, everything is working fine. So you see there's no problem with this motherboard here. So it is working fine. I just replaced the regulators and the resistors and we got the display. So I think initially they received this motherboard with one of the regulator got shorted, but they did not maintain a proper airflow when they removed the regulators. So that's why they have blown out some of the components nearby and it became unrepairable. So when you are removing the regulators, you need to maintain a proper airflow so that you don't blow away other components nearby it. Okay. So anyhow, we have a problem here that we are not getting power for the GPU in this motherboard. So let me show you that. So I would have repaired that as well, but I wanted to show you the importance of resistors in the feedback line in order to get the output voltage. So these two are inductors that supplies power for the GPU, and let me show you the voltage on that GPU right now, and we don't have any voltage there. If you check this, we don't have any voltage. The reason is, so let me disconnect the adapter. So the reason is some of the important resistors were missing. 1, 2, 3 and 4. These 4 resistors are very crucial and they provide feedback line into the regulator here that generates the core voltage for the GPU. And these regulators are missing and that's why we are not getting a voltage for the GPU. I have replaced this regulator here, but I don't have a motherboard that has this regulator, so I bought a new one, but I couldn't find the exact value for these resistors here. So anyhow, I need to find all the motherboards that I have with me so I can check whether I have these values of resistors. So now let me open the schematics or similar schematics. Through that I will show you the values of the resistors and the importance of these resistors in this place here in order to generate the core voltage for the GPU. Okay, so this is the reference schematics I used to repair this motherboard here, and you can see its part number on top here. So this part number is little bit different with the motherboard that we have with us. Anyhow, you can use the schematics to repair the power sections in this motherboard here because both of them are same. So now let me go to page number 46 to locate our GPU core regulator. So you can see which is VGA core. So this is the GPU core regulator. And here we have the part number which is RT8816BGQW. Actually, I don't have the regulator with the exact part number, but I have the A version of this one, which is RT8816AGQW. And I cross-check with the datasheet and they both are same and you can use it interchangeably. So go to datasheet. So here we have the A version, and going down and you can see so GPU and CPU core power supply, and these pinouts are all same with the B and A version. So on this side here we have some important resistors. So these are the resistors that is missing on this motherboard here, and these resistors are really important to maintain a proper voltage at the output point on this point here. And you can see these are termed as reference, all reference voltage. So and we need to find a voltage on this point as an output voltage on pin number 8. So if you go to datasheet again, go to pin number 8, yes, this is a V reference and a reference voltage output. So you need to find a voltage output on this pin approximately around 2 volt. Okay, so we need to find that before replacing this resistor here. Okay, and if you look at the values of these resistors, so we have decimal places on the values of these resistors, and the tolerance is 1%, so it should be very precise when changing these resistors here. So then only we will have a proper voltage on the output line. So let me try to find on the motherboards that I have with me and see whether I can find these resistors here. So altogether 1, 2, 3 and 4 resistors are missing. Actually on the schematic they are referring as 2 resistors, but on the motherboard we have only 1 resistor instead of these 2 resistors. So we can join these two values and place only 1 resistor on the motherboard. So altogether we need 4 resistors. Okay, I managed to get all 4 resistors from the scrap motherboards that I have with me. So I'll just show you the readings of each of these resistors here. So just look at the multimeter. Okay. So 16.4 kilo ohm. So actually we should have 16.9 kilo ohm by adding 16.5 kilo ohms and 0.3, which is 300 ohms. So we should have 16.9 kilo ohms, but I couldn't find it. So I just took this one from a motherboard. So just we can replace it and see whether we are getting any voltage. So the other resistor, yes, 20.4 kilo ohms, so that is fine. The other one, yes, 4.32, so that is also fine. And the other one, wait a minute, so 6.2 kilo ohms, which is 6.19 kilo ohms, so that is also fine. Okay, so now let me replace all of these resistors near this regulator here. So except the last 2 resistors, all other resistors are exact in their value, and see whether we are getting a voltage on the inductors of the GPU. Okay. Okay, so now I have installed all 4 resistors here. So 1, 2, 3, 4. And let me connect the adapter and see whether we are getting the reference adjust voltage, reference in voltage, and also the inductor voltage for the GPU. Okay, so let me connect the adapter. Connecting the adapter, yes, connected. And you can see the ampere reading is 30 milliamps, then back to 6 milliamps. Okay. Now pressing the power button. Yes, the board has turned on 800 milliamps, so it is drawing. Checking the voltage on the reference adjust pin, and I'm getting 0.9 volts, so that is fine. And on the reference in pin, I'm getting 0.722 volt. And if I check the inductor voltage on the other side, and you can see we are getting 0.27 volt. So according to the data sheet, you can see the inductor voltage is same as the reference in voltage into the regulator here. So you see we have 0.72 volt, and also on this side on pin number 7, which is the reference in voltage. Let me turn on again. Okay, right, reference in voltage, and we are getting 0.722 volt. So both of them are similar, the voltage is similar. So the reference the GPU voltage is dependent on the reference in voltage into this regulator here. So that's why the data sheet was telling that the reference in voltage is necessary to get a GPU voltage. So as all of these four resistors were missing, so there is no reference voltage and the GPU voltage was absent and the regulator did not generate those voltage. Okay. So now let me assemble this inside the laptop, and we need to check the GPU whether it is working fine on this motherboard here. So we can do a benchmark test or GPU stress test and see whether it is working fine. So if there is any problem with the GPU or on the regulator that we installed here or in the resistors that we installed in this motherboard, and the GPU stress test software may crash or the laptop may shut down. So if nothing happens, then we can confirm that our work is fine. Okay, so now let me assemble this inside the laptop and go for a checkup. Okay. Okay, so the laptop is working fine. You can see we got the display, and up to now everything is fine. So let me go to the task manager so we can check whether the GPU is enabled. And yes, so here we have GPU 0, which is the integrated graphics by the CPU SoC, and here we have the dedicated graphics, which is NVIDIA, and both of them are active, and NVIDIA GPU is also recognized here, so I think it should be working fine. So here we have a stress test software, which is this one here. So we can run this software and test whether the GPU is working fine in this laptop here. Okay, so let me run it. So if there is any problem on the GPU, the software may crash. So up to now the video is okay. So you can hear the fan spinning too fast. So the GPU is now in a high performance mode. So let me benchmark this GPU. So I think the GPU is working fine, so there's no problem up to now. Yes, so we got the result and we have 34 frames per second. The GPU can handle up to this point and the score is 1435. So this is what we get. So this NVIDIA GPU has 4 MB dedicated memory. So okay, so we don't need to go deep into this thing. So just we need to test it. So everything is working fine. Okay, so let me close it. Yes, so everything is working fine. So we have done a good job. So thanks for watching, guys, and stay tuned for our future updates, and see you later in a new video. Okay.